Interesting one. It came out of nowhere. Mark Cerny has basically released a video alongside AMD's Jack Hewin talking about, what can we say? The future of PlayStation technology, the fruits of the Project Amethyst initiative. Lots going on there. 3 key points that I think we can talk about, takeaways, if you like, from the presentation. We actually had a Q&A with Mark himself, an email Q&A, so we'll try and weave in some of his responses into this. But basically, we've got 3 announcements here. Basically, neural arrays. It's essentially a way of bringing together compute units to act in a more cohesive manner when dealing with machine learning tasks. Secondly, we have Radiance cores, a dedicated hardware block designed for unified light transport. This sounds rather like the RT cores within NVIDIA's architectures. It's finally here on AMD and presumably in the next PlayStation console. And another new technology that's looking really impressive here, universal compression. I think this is essentially a technique for improving bandwidth on the GPU, which is something where we're seeing very, very small increases gen on gen. So this is like an attempt to address that, so to speak. But I'm going to go to you first on this, Oliver. What were your big takeaways from this?
I think this is very interesting. I think you have 3 separate kind of approaches here, in the sense that the Radiance cores, they look a lot like the NVIDIA RT core. Perhaps they're more expansive in their usage, but they seem a lot like the RT core. Then you have the neural arrays, which seem like an area-efficient way of doing fast machine learning. Obviously, it's kind of similar to what Sony did with PS5 Pro, but there's bigger scope here. You have coordination between CUs, possibly, have bigger models, bigger tiles, things like this going on. So that should certainly be helpful. That's kind of, it's not a tensor core. It's a different way of doing it. That's kind of their own way of doing something that NVIDIA has already done in their architectures. And then there's the universal compression, which is kind of an intriguing little black box, probably some kind of, lossless compression technology that is probably complementary to the DGF, and 3 different approaches there. One kind of orthogonal to NVIDIA's approach, one kind of similar to NVIDIA's approach, and then one kind of their own thing that's quite interesting and new. But I found this kind of interesting, especially the universal compression aspect of it, because Cerny was kind of a little bit more concrete here in terms of what he was interested in with universal compression. He's saying the extent to which the actual bandwidth of the GPU will exceed its paper spec is something he's interested in. And the problem here that Mark is pointing out is that next generation GPUs are not scaling well in terms of their memory controllers. Mark answered a question of ours here where he basically said that bandwidth is coming with a very high cost on next generation GPU architectures. So if there's a way to make that more efficient, the gains can be quite large. And I think here we're seeing something that probably dovetails with other leaks, other reports that are coming out of different sources, where, the PS5, PS5 Pro, PS4, PS4 Pro, those will have 256-bit memory interfaces. Probably the next generation memory interface on PS6 is not going to be as large. Maybe it's going to be 160 bits, 192 bits. If you do some quick math with like 32 gigabit per second memory, that is actually not a very large increase in memory bandwidth over like a PS5 Pro, and a much more moderate increase in memory bandwidth, maybe a 50%, increase in memory bandwidth, 60% increase in memory bandwidth over the PlayStation 5, which is historically, that's a very small increase in memory bandwidth. Obviously, expectations coming out of this, Kepler L2 has been saying that RDNA 5 will be very similar to Blackwell in terms of how performant it is at accelerating machine learning and ray tracing operations. And I think what we're seeing here is an architecture that can probably scale well for the next 10 years of games, whereas RDNA 4 famously does not scale very well to path tracing workloads, right? Does not actually fare all that well in these really advanced games. Fares very well in RDNA 2 friendly ray tracing workloads, but probably is not the architecture that you want going into the 2030s, right? At this point. Mm-hmm. And there's also one last thing I wanted to talk about here, which is they talk about bringing these innovations to gaming platforms. Jack mentioned that. And I think the implication here is that obviously Amethyst, this is an AMD and Sony co-engineering effort. This tech will show up in the PC and in the consoles. It will show up in all those platforms. And I think Sony is really interested as kind of a steward of gaming more broadly, of AAA gaming more broadly, however you want to see that. They're very interested in making sure these technologies permeate different platforms. That'll be PS6, that'll be next generation Xbox, that'll be PC, that'll be all kinds of different products within that PC family. They want the AMD next generation architectures to be common so developers have an easier time. So they end up obviously boosting their game success on PlayStation, even if they are third-party games.
Mm-hmm. Yeah. John, what's your initial view of this?
So yeah, Oliver kind of already broke down all the individual pieces, but when you step back and look at it more holistically, and I said this earlier to you guys, is like it basically feels like AMD adopting the roadmap that NVIDIA set back in 2018, which obviously would not have been a feasible thing to do in the consoles at that time, given where they were in development and their release window. But I do like some of the additional changes. But the thing that really stood out to me, and we actually asked Mark about this. You asked him, like, with a strong focus on machine learning and innovation and whatnot, where does rasterization performance sit, right? And I think this is always kind of one of those questions where it's like, so what happens with traditional performance? And this is what made me think of NVIDIA, where he's basically saying conventional rasterization is, of course, still very important, and they will seek out improvements where possible. But I think we can all agree that the step change will come from ray tracing and machine learning capabilities, which is, I think, a drum that we've also been beating for quite some years now at this point. But it's been a painful transition. And this actually made me think about why has this transition been painful for people? I mean, it's always the case when you introduce new technologies that there is that growing period, both from the development side and also just like the user hardware side, right? And implementing new features, they're not going to be as performant as people may like compared to the old things. But I feel like where we're at now, removed from the initial wave of all these new features hitting, it's become a lot more mature at this point, and AMD is approaching this, I think, with Sony from that perspective of like, okay, this is what works best. This seems to be the direction that the industry is moving. Let's build out some of these new features with this in mind. And hopefully that should allow us to essentially solve some of those major issues, which has been, of course, in the console space. When ray tracing is used, for instance, we're often left with major sacrifices in terms of image quality and performance. Yeah. And on the PC as well, if you were with a lot of AMD GPUs, especially games that went heavy on ray tracing, you would have to give up a lot of performance to get where you might want to be, right? And I think fundamentally, this is what users didn't like. So to me, this seems like, all right, this is a real attempt to get a console that can do these fancy new features. Well, not so new anymore, but handle these types of workloads smoothly, but also do so at a fidelity that is acceptable with good frame rates, good image quality, and all that. And that's what that universal compression kind of stuff kind of came in, which I thought was interesting, since it's this idea of like basically streamlining the data before it gets the memory. And I thought this made me think about like, the whole thing with upsampling techniques, right? Like PSSR, machine learning there, where you're like, okay, we are limited in certain areas. Let's try to offload and do it this alternate way. Or with something like frame generation, right? The whole idea of frame generation is like, all right, we're CPU bound in these games. What if we take advantage of GPU capabilities in this other area and essentially increase the visual performance here? So by essentially, since the memory controllers are not scaling at the same rate as other aspects of the hardware, this is like a way to sort of work around that. And it seems very clever on paper, and I'd be curious to see what kind of efficiencies this brings to the table. But it should allow for, more efficient rendering on the GPU side, where in areas where the memory controller would struggle to scale, right? Mm-hmm.
Yeah, we actually had a comment from Mark about the application of universal compression. I'll just quote here. For universal compression, I have high hopes for synergies with ML. For example, FSR and PSSR are recurrent neural networks that write feature maps to system memory. How well will those feature maps compress? Radiance cores are similar. They're obviously a great way to do the processing, but I suspect we'll need to get prototypes into the hands of game developers to understand the degree to which they will be able to quote unquote level up their engines. So I suspect they've basically done the core engineering on what universal compression actually is, but the actual applications of it remain to be seen. How big the win will actually be and how developers will actually take advantage of it, I guess. And I think something to stress at the end of the video was Mark was saying that this is all still in the simulation phase, right? So there's a long way to go yet. I think there is also another interesting thing to come out here, which is that, and we actually asked Mark straight out about this. I mean, this was actually a question of yours, I think, Oliver, whether the leap from PS5 Pro, which did have a machine learning and RT focus, to whatever's next? Is it more of a progression or a step change? And, well, it does look like a step change, right, Oliver?
It does. It does. Mark is basically saying that because of Project Amethyst and because they're co-engineering hardware for development with AMD, and because that hardware is showing up in a ton of different platforms here, they're really trying to create kind of this convergence of machine learning and ray tracing and all these kinds of technologies that will serve as a basis for future hardware. That's kind of a more kind of step change approach. Whereas if you look at something like PS5 Pro, obviously you're just trying to extend what a PS5 is. And as Mark put it, they're just in service of greater graphics, right? And I think that the PS6 is going to be a key part of the spec for next gen hardware. And to the extent we do see proper next generation software early on, which is kind of debatable at this point, given all the reports about an extended and very, very lengthy cross-gen period, that is going to be really critical for software having kind of a common spec to build to and hardware that is both more or less powerful than that, but is within that spec of technologies as well.
An interesting thing that makes me think of, though, is like you mentioned, you're right. We expect a very long cross-generation next generation, right? But if we're seeing game engines push more into these sorts of feature sets, you start to deal with things that the last generation machines cannot handle especially well, right? So let's say your entire game's visual target is arted up around like using the full suite of ray tracing features, right? Naturally, when you do that, you need to consider fallback solutions, which of course adds to the budget, the time, development, and all that, right? And that might be necessary then, which could increase cross-generation development budgets and time more than what we've seen in the past, where it's usually just adapting what was there and then sort of like upping the res and frame rate and stuff like that, right? And then sort of like allowing it to scale across platforms. Here, it's like, all right, well, if we're doing everything with ray tracing, just as an example, the original PS5, it just doesn't have the hardware to handle all of these features at the same time. So now we have to come up with an alternative solution, which creates some other interesting challenges and makes me wonder, like, how many games will we see actually leverage these features properly? How long will it take to get there, right? But at the same time, I guess the positive side is that we also know that the PC has existed alongside these consoles, right? And we've seen plenty of PC games absolutely leverage these features in beautiful ways, even going back, 5 years at this point. I mean, you look at Cyberpunk 2077, it's an older game at this point, but boy, does it still scale up really, really well. So that at least gives me some hope that we could see similar leaps where you get more like what you would expect from higher end PC graphics on the console, and then sort of like these downgraded last generation titles.
Yeah, I think there was an interesting question that Alex brought up for Mark, which was essentially asking about the extent to which developers will have low-level access to that machine learning hardware. And Mark basically said there are many types of machine learning, and as a result, multiple tool chains will be needed. Small models need an ONNX graph compiler. LLMs need a more specialized tool chain. And when ML is integrated into a pixel shader for applications like neural textures, yet another kind of support is needed. To directly answer your question, though, I think over time we'll learn how important it is to be, quote unquote, close to the metal on this particular architecture. And a question you came up with, Oliver, about Mark was famously surprised by how quickly ray tracing was taken up on PlayStation 5 and whether the same thing will apply to machine learning. What will machine learning even be in a few years' time, Mark says? I think we're all guaranteed to be surprised. Having a powerful and flexible architecture for machine learning is definitely going to help with the challenges ahead, which, again, kind of causes a bit of fiction if we're right in that, cross-gen is going to be even more prolific on the next generation than it was in this one. What do you think, Oliver?
I think you're going to end up having two tranches of software, one that is basically an extension of current generation software, and then one that is true next generation software. That's what I suspect. But within that first category, you can still do some pretty impressive things. Obviously, we have games like Cyberpunk, Doom the Dark Ages, even games like Dying Light 2 that are pushing out really advanced ray tracing technologies on PC. That's all work that could be brought over to PS6, right? Conceivably. But in terms of like actual machine learning integrated into your game at a low level, not just using PSSR, not just using like a frame generation technology, but actually building that into your game, using all kinds of neural networks for different kinds of things. This is area that's still being ideated for game development, and I suspect that work will only really commence in earnest for commercial software when you can actually ship on hardware that actually has this acceleration built in, instead of trying to ship your game on like PS5, trying to implement all these neural networks. It's just not really feasible, right? Or like a Series S. This class of hardware is not going to be appropriate for this level of acceleration of next generation graphics technologies. But I also think that Sony is uniquely positioned, in a sense, to deliver those technologies early, because obviously Sony can deliver exclusive games that only have to ship on PS6. Potentially, that's a possibility, right? And maybe the PS6 handheld. I don't know exactly how they'll split that one, but it could be the case that Sony is actually first in the market with big new games targeting the PlayStation 6, targeting next generation hardware exclusively.
Yeah, interesting. Let's take some supporter questions. We're going to kick off with this one, and we had a bunch of them, by the way. We'll kick off with this one from Darsharko in brackets Dan. Happy half fortnight, lads. So Cerny opened his secret lab door. The Amethyst special source will have quote-unquote Radiance cores, quote-unquote universal compressions, and let's not forget last week's news that RDNA 5 will have hardware acceleration for DGF. I'm getting confused. Is this redstone, an amethyst stone, or even a green stone? Will we soon be basking in the radiance of these seemingly about-face decisions? I don't think they're about-face. It says to me like there's a broad direction of travel with everything heading towards balancing rasterization and the increasing demands there with really exciting stuff that's happening with ray tracing and machine learning. I think what's really interesting from my perspective is, I think in the last Amethyst video that went out, Mark was talking about AMD producing this stuff for the PC market relatively swiftly, which I guess is RDNA 5, whereas for PlayStation, and he reiterated it in this video, it's actually a few years off. What fascinates me is the level of cooperation that's happening over multiple years to get this off the ground. And it is seemingly about, I don't know, I just think that this partnership is absolutely fascinating because I think obviously Sony getting more involved in hardware design and helping out on the software side and on the conceptual side, it's hugely valuable to AMD, where it's really felt kind of lacking in recent years. Whereas, and they also, of course, get to move, get into the ground floor, so to speak, on the hardware designs that they'll need. As opposed to sort of dipping into the AMD roadmap. John, any thoughts?
Man, this is the future they wanted with the cell processor, right?
Right.
Get down on the ground floor, throw it in some refrigerators. No, so actually, the thought that came to mind actually goes back when you were talking. You were like, oh, Cerny said it won't be ready for a few years or so. If we take that at face value, that's 2029. That's a 9-year console cycle, which is interesting.
Or an 8-year one.
What do you mean?
Well, the consoles came out in 2020, right? And a few years can mean 2028 from now.
Yes, that's like 3 years, but yes, okay. But yes, it could be. That's a very long cycle, and it got me thinking about where does that handheld fit into this?
Right. Okay.
Right?
Yeah.
Because there's been all these rumors about the handheld now, right? So I'm wondering, could we see that handheld perhaps release, like, I don't know, next year?
Right.
Something after that? I don't know. But like in the near future, imagine you have a handheld that also sort of works with PS5 class software, like we've kind of discussed as a possibility. I don't know, that makes an interesting sort of like way to continue the generation forward.
Yeah.
Because we're also at this part though where like having software ready has become the actual bottleneck for any hardware at this point, right?
Yeah. Mm-hmm.
Like we're deep into the PS5 cycle, yet we're still years away from like an actual like Naughty Dog game releasing on PlayStation 5.
Yes.
Like it's honestly nuts. So like let's say they get Intergalactic, I think it was called. If they get that out, when does the next Naughty Dog game hit?
Right.
It's like it just creates this. We're in this weird cycle where it's taking it so long to make these games now, that the games themselves are kind of like changing just the way, like they're too slow for the hardware cycle, it feels like, which also kind of makes me wonder if like this whole 2028, 2029, even 2030 release time period for PS6, even though it seems extra long, kind of makes more sense now when given that. So like hardware in general just isn't the big bottleneck anymore, right?
I certainly concur with John there, but I should chime in here with just a little bit of information from Notorious Leaker, as we mentioned earlier, Kepler_L2. He says the current plans for PS6 are 2027, but he says they may slip. So,
all right.
So you guess, you know, at this point they're talking about hardware only existing in simulation. Then you got like tape out for A0. That's probably some time away. A1 still looking further out. If that goes well, early dev kits, like you'd think maybe 2027 would be their earliest. So maybe it'll get pushed into 28. Who knows at this point? But that is kind of an interesting element of it where I do agree. The hardware cycle, even a 7-year hardware cycle, historically, this is a slow console cycle. 7 years was not the norm for a long time in the early era. You know, certainly in the 2D era, in the early 3D era, that was not the norm. So to have a 7-year console cycle and to be talking about Naughty Dog, who shipped, I mean, geez, how many games they ship on PS3? 4 games, I think? Uncharted 1, 2, 3, and The Last of Us?
Last of Us. And then on PS4, they did Uncharted 4. They did the second, what was it called? The second Uncharted 4 based game, which is going to be decent. And then they did Last
Legacy,
of Us 2.
I think, right?
Lost Legacy. So they basically did 3 games last gen. This far, they contributed to The Last of Us Part 1, but that's basically like a remake kind of thing. So we haven't had any new title from them yet.
Yeah, so that's pretty extraordinary sitting here. Maybe we'll get one game 6 or 7 years into PS5, and then all of a sudden we're talking about, okay, 2034, 2035 for their swan song for PS6, their only title, their singleton for PS6. I mean, that's an extraordinary pace, but I'd certainly agree that's a serious issue, and hopefully that'll be overcome.
I mean, you got like Ben's. There's Ben Studio, hasn't done anything yet this generation, right?
Well, Days Gone remastered.
I mean,
I think maybe part of the issue here in both cases is that they were on the games as a service tip, which didn't pan out.
Right.
And a lot, basically man years and huge amounts of millions of dollars just disappeared because of that. Let's get back on topic. Another supporter question here. Dudley the Gentleman asks, good day, fellow starter strugglers, ! What features or performance do quote-unquote neural arrays unlock that dedicated tensor cores don't? Are these technologies complementary, the same, or orthogonal in functional usage? Well, they're talking about compute units. So neural arrays are basically a new way of coordinating those compute units to do ML-related tasks. So it's not really a tensor core as such. It's I don't know. It seems to me, John, that there's quite a lot of area efficient stuff that AMD does, whereas, in order to get the most out of the silicon, whereas NVIDIA tend to concentrate more on dedicated hardware. And I think that's what we're seeing here. Let's go on to this one from Sheddy 1982 Rome. Good morning, afternoon, and evening, gents! ! With the interview between Mark Cerny and the head of AMD discussing the new technology that will be inside the PS6. Does that mean that they have basically given up on the PS5 Pro? Thanks in advance. I think that, this is years away, the stuff that was being discussed here. So a game that has a lot of effort put into it on PlayStation 5 will have the additional engineering put into it on PlayStation 5 Pro. So I don't think that's really a problem at all.
No, I mean, PS5 Pro occupies the same space as PS4 Pro, I would say, really. It's just, it's a complementary machine.
And there's like next-gen PSSR based on FSR4, based on that neural network. There's some good stuff going on there. I don't think that they're abandoned.
Yeah, there's research that was done for PS5 Pro that, is useful going forward.
I'm sure.
As well.
Yeah. Any final thoughts on this, John? I'm just really excited by this on multiple fronts. I think we haven't, I don't know, I was just going back to like the PlayStation 3 era where we would learn about the existence of the console years in advance, when they were talking up the cell processor many, many years before the PlayStation 5 actually arrived. And it kind of did generate a hype for the gaming experiences to come. And we kind of lost that, but it's back now. We've got these presentations from AMD and Mark Cerny clearly working in partnership, getting us excited about what's to come.
I think the approach they took with PS3 and the lead up to its release was not wrong. And I think the PS3's foibles can't be blamed on that specifically. The hardware had other issues, right? And I think when they went to PS4, one of the lessons there is they just tried to like simplify and streamline the messaging to get back on track. And they are back on track. And I think now there's nothing wrong with sort of taking that similar approach of like breaking down discoveries and like innovations that they're currently working on, well in advance of the actual console release, which is very much in line with what we saw with the cell processor and everything they promised for the PS3, right? And I think that's great. Like additional openness from these companies is something we should definitely welcome, and it gives some more insight into where they're going. And I'm sure from their perspective, it also gives a little bit of insight into what the audience might think, right?
Yeah.
So you get a little bit of feedback here and there where you're like, okay, that's interesting. The perception of this. So yeah, I like to see this, and I hope they continue with these sort of like small segments, giving us a peek behind the curtain and some better understanding as to where they're going. Though I sure would love to see a guest appearance from the man himself, Kutaragi-san. But not that he's involved anymore, but man, he could come in and give it his blessing.
Final thoughts, Oliver?
Well, John, you bring up the PS3 and potentially the excitement that's been generated around this announcement, this kind of pseudo announcement that there might have been for the PS3. But this is kind of interesting because it's completely different to that PS3 approach, where it's like, yeah, we're developing shared hardware that everyone is going to use. Basically, everyone across the industry uses AMD hardware is going to use. Whereas with the cell, it's like, okay, Toshiba, Sony, and it only ended up showing up. And did it end up showing up in any other devices than the PS3 in the end?
Yeah,
it did.
The
right?
Xbox 360
CPU core basically ended up in the Xbox 360.
The whole PowerPC CPU core, the IBM.
Yeah, but
was
there any other discrete device, maybe like a supercomputer that used cell, or was it just PS3?
I don't remember off the top of my head.
Yeah.
No. I mean, there was the GS Cube for the PS2.
I mean, there was the supercomputer the military had with all those PS3s networked up, but that's not really what I'm thinking of. Sorry.
Oh yeah,
bit
true.
of a tangent. But yeah, it's a different approach. It's a much more realistic approach, and it's an approach that's designed to yield good results. And especially in this era, like we were talking about earlier, about like games taking 7-8 years to develop. I do think you need a common base to develop for. And even Sony in their position, they're thinking about games possibly getting ported to PC, and then of course needing to support all their partners who are shipping a ton of games on PlayStation consoles. So yeah, I think this is great. Personally, I'm not too fussed about. I think PS6 should arrive when it's ready. I'm still relatively happy with PS5. Games are by and large running well. I've just covered Battlefield 6, which obviously runs terrifically on PlayStation 5. And I think the hardware is doing okay, in part because games are being designed around that hardware, so no one's doing anything like too ambitious with machine learning or ray tracing that won't run on the consoles for the most part. Although some developers are pushing a little bit hard. But I'm very excited for next generation console hardware, and I'm very excited for RDNA 5 for sure.
I will say real quick, Oliver, that's a good point. And this is something I think deserves more appreciation, is this generation, we haven't had consoles running this well for so long.
Right.
Like the last 20 something years, we haven't seen anything like this. The PS5 generation is excellent. There are so many 60 frames per second games this time. Nearly every game that releases is 60 frames per second.
Yeah.
We do have some exceptions, of course, and there's definitely some occasional games with issues, but even when the games have issues, the issues that they do have, they're nothing compared to what we saw in the last generations.
Right.
Yeah.
Right. So like we've made tremendous progress in terms of delivering smooth experiences for users.
Yeah.
Absolutely.
I'm just really loving these videos that Sony are putting out in association with AMD here, because, we're getting a roadmap of the future, and, it's just fantastic, I think. Also, of course, as you say, John, there has been like quite a rocky road in terms of the perception of the arrival of ray tracing and machine learning features. And I do think there needs to be some sort of campaign to actually say, hey, this stuff is really, really cool. It's It's still nascent technology, but it's going to be solidified in this brand new technology we've got, a few years down the road, or possibly a lot sooner when AMD's next wave of graphics cards come out. And I'm just loving these discussions, right? I think it's absolutely fantastic. Anyway, that's all for now. We'll be covering a lot more news in the next edition of DF Direct Weekly coming soon. But for now, like, subscribe, share if you want to bring some level of personal interaction to this video, and ring bells for allegedly instant notifications. Just a small reminder that Digital Foundry is now a fully independent media outlet. So please do consider supporting us via patreon.com/Digital Foundry. But regardless, thanks for watching and supporting Digital Foundry.